here we go. We're going to do a significantly more complicated problem on the same worksheet. It's number 20. And we'll start here with negative 19 on both sides. We're going to clear the numbers on, put the numbers on one side and put the variables on the other. In order to do so, we use the golden rule of equations and inequalities, which means that whatever you take away from one side, you have to take away from the other. So we end up with down here 4n, this 19 minus 19 is 0, is less than or equal to 5n minus 16. Now, to get the letters on the left-hand side and the numbers stay on the right, we want to subtract by 5n here. We're just going to follow our principles and see where they take us. We want to make sure we do it on both sides. So we end up with negative 1n is equal or less than or equal to negative 16, right? Because this becomes 0. Now, following our principles, we want to have this to be n, not negative 1n. So we have to divide both sides by negative 1. And when we do that, it seems straightforward. We get positive 16 on this side, and we get just n on the left-hand side. But you have to remember that when we divide or multiply by a negative number, we have to switch the sign. So we end up with n is greater than or equal to 16. So be very careful to remember to switch the signs. And I'm just going to write it here just to remind you. And then we go over to this next part. So 12n plus 15 is less than 5 plus 10n. We're going to start with subtracting 15, and then we're going to go from there. Subtract 15, both sides. That's part of what we do. And then we get 12n less than negative 10, because 5 minus 15 plus 10n. And then we want to bring the n's on this side. We're going to go ahead and subtract 10n from both sides. And we get over here 2n, and then less than negative 10. We're almost done. We just divide by 2 on both sides. In this case, we did not divide by a negative number, so we don't have to worry about flipping the signs. We keep them the way they are. We get n is less than negative 5. Let's look at what this looks like on the number line, and let's figure this out. Remember, this is an or statement. It can never change. It's an or from the beginning. And it stayed that way the whole time. So we expect there to be handlebars. Here's our number line. We're dealing with 16, a pretty big number over here. I kind of give it some space. We're looking at a closed circle because we're going to include 16 in the solutions. Over here, negative 5. We have an open circle, and it's going to be less than negative 5. 0 is going to be somewhere in here, approximately. Greater than 16, greater than or equal to 16, solutions, examples, always encourage you to put in, think of examples, 17, 20, think of real numbers, 23. All those are numbers that are going to work out over here. So now we know we can draw the line to go over here, and it's going to go off to infinity, because this could be an incredibly, ridiculously large number. And then on the left-hand side, we want to go less than negative 5, so examples are going to be things like negative 6, negative 10, negative 100 or whatever, very small, very, very far left numbers. And then this is going to be the number line going left to signify that, and a lot of little numbers, possible solutions, those are represented by. It could be little tiny fractions and decimals, and we want a solution set that reflects all the possible solutions, and there are many. So we again have that handlebar effect. We've got a person on a motorbike or any kind of bike and who uses the handlebars, and that's the idea. So this is what I call this a handlebar effect. So handlebars, and this is an or statement, and it's a compound inequality with an or statement, and we call it handlebars. So let's move on. Let's check out and inequalities in our next video. Thanks.